Hello, this is Roger Koch Barr for the Bioelectricity course once again. This is week number 5 and segment number 7. Now before we go any further, let me ask you the following. Have you ever gone to the movie at a theater and you thought you were getting there at the right time, but the first thing that came up on the screen was the preview of some other film or an advertisement or a cartoon or something else? And then there was another one and another one. And before long you started to think, will we ever get to our movie? Well, eventually you do. So you're probably thinking the same thing right now in this course. Will we ever get to working on the axial current and the transmembrane current, or will these preliminaries go on forever? Good news, we have just one more. And here we go, and we're going to do it rather quickly. We want to look at the relationship between the intracellular current and the extracellular current. Suppose I draw on my figure the intracellular current for segment 2. So let me draw it, and I'll draw it right here. I'm going to label that I2, intracellular current for segment 2. You notice that in the way I'm doing this notation, this is point 2, location 2, and I'm thinking of the currents as being in segments to the right of the location. So here's the x-axis, IE2. I2 is just to the right. Suppose now I also draw the extracellular current for segment 2. That will be up here, so I'll draw IE number 2. What is the relationship between these currents? And the answer to that is that under all circumstances, IE2 is equal to the negative of II2. It is not a conclusion from the data, it's a requirement of the model. And the reason it's a requirement of the model is that we have only one path in the intracellular and only one path in the extracellular. So every segment, what's happening on one side has to be the negative of the other. That's so because current has to flow in loops. Now, you could say, well, can there ever be an exception? Yes, there can be an exception. Let me show you what the exception is. If you have a stimulus, so I'll draw a stimulus electrode. It's coming from the outside, and it crosses over several segments. Then under this circumstance, with a stimulus, I can have an extracellular current, an intracellular current, and the one is not the minus of the other. So where stimuli are present, this rule of opposites need not necessarily be so. But most of the time, absent stimuli, that is to say, a stimulus from the outside that crosses over the segments, we have IE at some point. I is equal to I at some point I, but with the opposite side. This will turn out to be critical in a little bit. Thank you for watching. We have now put together all the pieces in this complicated set of items, just about as complicated as the different angles on these Duke University dorms, and we'll make use of these different ideas in just a moment. Thank you for watching.